Hi everyone. In this video we're going to talk about a new factoring strategy. So we learned last week that we can take standard form quadratic equations and can rewrite them in factored form as two binomials being multiplied together. We do that because factored form equations highlight the x-intercepts of the function. So last Tuesday, we learned about that connection between x-intercepts and the factored form of quadratic equations when a was 1. And when a is 1, we use something called the x-game to factor those quadratics. Today we're going to learn what to do when a is not equal to 1. So what happens when there's a number in front of that leading quadratic term? So we have 4 steps that we're going to use to factor quadratics where a is not 1. So our very first step is we're going to look for any common factors among all 3 terms. So any number that divides into all 3 of those coefficients. So looking at this sample problem, where it says factor 9x squared minus 6x minus 15, I can see that all 3 of those numbers are divisible by 3. So that's the first thing I'm going to do, is I'm going to factor that 3 out in front, and I'm going to rewrite this as 3 times, and then 9 divided by 3 is going to be a 3x squared. 6 divided by 3 is going to be 2, so 2x. And 15 divided by 3 is 5. And that's a little messy. Let me rewrite that. So now the trinomial we're focused on, 3x squared minus 2x minus 5, is a little less intimidating. The numbers are smaller and easier to work with. The next step is to find a pair of numbers that multiply, whoops, I swear I know how to spell, multiply to give you a times c, and add to give you b. So remember that the number in front of the x squared is our a, the number in front of the x is our b, and the constant at the end is our c. So a times c is 3 times minus 5, which is minus 15, and b is minus 2. So we're going to go ahead and play the x game really quick to find factors of negative 15 that add to negative 2. So multiply, add. 15 has a limited number of factors. I know I can do 1 and 15, or I can do 3 and 5. 3 and 5 make a little bit more sense. And then I have to figure out the signs on those. I know they're opposite because a times c is negative. And I know the bigger number should be negative because when I add them, I get a negative answer. So plus 3 and minus 5. So we've found the pair of numbers that we want to use for our next step, plus 3 and minus 5. Step 3 says use these numbers to split up the middle x term. We can write minus 2x as negative 5x plus 3x, or as 3x minus 5x. So we're going to make this substitution into this trinomial. So we're going to rewrite it as 3 and then 3x squared, and instead of minus 2x, minus 5x plus 3x minus 5. So far, we've done step 1, we've done step 2, this is step 3, we're almost done. Step 4 says use grouping to factor the quadratic expression. And grouping means we're going to put some parentheses around these and group them together. And when we do that, we always group the first two terms together and the last two terms together. You'll notice there's a plus sign between those new parentheses. This is still a big long chain of addition and subtraction with the trinomial. I don't want to turn it into a multiplication problem while it's still a big long string of addition and subtraction. Once we have them grouped, we look in each of these groups for something they have in common. 3 and 5 don't have any common factors, but x squared and x both have a common factor of x. So I can pull that x out in front. 3 and 5 don't have anything in common, and x and no x don't have anything in common. So the only thing I can pull out here is a 1. Everything's divisible by 1. So we're going to go ahead and rewrite this with the factored stuff pulled out. So for the first grouping, I'm going to pull that x out in front, and then what's left over goes here. So 3 and then x squared divided by x leaves me with a single x, and then minus 5x divided by x, those x's cancel and leave me with 5. For the upper grouping, I'm pulling out a 1, and that leaves me with 3x minus 5. If you've done this step correctly, you'll notice that the binomials that are left behind should match. 3x minus 5 and 3x minus 5. So our last step is to factor those binomials out in front. We're going to divide by 3x minus 5. So we're left with 3. That was there before. And then we factored out a 3x minus 5. And what's left goes in parentheses. And I see an x and a plus 1. So a couple of things before we do some more examples together. First, you'll notice this is factored form, so I have two binomials being multiplied together. I also have a constant out in front, and that's okay. Second, when we went from step 2 to step 3 and we split up that middle x term, I put negative 5x first and positive 3x second. It's okay if you do those terms the other way around. It doesn't matter the order that those go in. That's just going to change the order on the binomials down at the bottom. But your answer is the same. As long as you have an x plus 1 and a 3x minus 5 somewhere in your answer, it's okay if they're in the reversed order. We know that we can multiply things in any order and get the same answer. Okay, let's do a couple so you can get a feel for this, and then I'm going to have you practice some on your own. So let's zoom in a little bit here so we have lots of room to work. So we want to factor 2x squared plus 7x plus 3. So we remember the first step is to look for any common factors. 2, 7, and 3 don't have any common factors. They're all prime. None of them divide into each other. So first thing, I'm just going to make a note. No common factors for the whole trinomial. So that means I go on to step 2. And step 2, I'm looking at A, B, and C. So A is 2, B is 7, C is 3. And we want to do A times C. So that's going to be 2 times 3, which is 6. And B is equal to 7. And we're looking for a pair of numbers that multiply to 6 and add to 7. And 6 only has 2 pairs of factors, 1 and 6, and 2 and 3. 2 plus 3 is 5, that's too little, so it must be 1 and 6 here. So 1 times 6 is 6, 1 plus 6 is 7. Our next step, we're going to rewrite that trinomial and we're going to split up 2x into 1x and 6x. So 2x squared plus 1x plus 6x plus 3. Our last step, we factor by grouping. So first 2 terms together, second 2 terms together, we look for what they have in common. In the first pair, they have x's in common, so I'm going to divide an x out. In the second pair, 6 and 3 are both divisible by 3, so I'm going to pull a 3 out. So for that first grouping, I have x, and then 2x plus, and anything divided by itself is 1, so 2x plus 1. And then I have 3, and 6 divided by 3 is 2, so 2x, and 3 divided by 3 is 1. Again, the check that I did it correctly is that these 2 binomials should be the same, and they are. So our very last step, we factor the common binomial out. So 2x plus 1, and then what's left over in the second binomial times x and plus 3. I know that this probably feels intimidating. This factoring by grouping process is new. We get better by practicing. So I'm going to do 2 more with you. If at any point you feel like you're confident, feel free to pause the video and try it on your own, and then go to the end of the video to check your work. And then after this video, you're going to log into Delta Math and complete more practice with this skill. Okay, second one, similar idea. So factor 3x squared plus 10x plus 8. We're going to go through our step list. So first step, we look for common factors. 3 is only divisible by 1 and 3. 10 and 8 are not divisible by 3. So no common factors. So we can skip step 1. Step 2, we look for A, B, and C. A is 3, B is 10, C is 8. A times C, 3 times 8 is going to be 24. And B is 10. So we're looking for a pair of numbers that multiply to 24 and add to 10. So 24 has lots of pairs. So off to the side, let's look at 24. We have 1 in 24, divisible by 2, that's 2 in 12. It's divisible by 3, 24 divided by 3 is 8. And then it's divisible by 4, and we get 6. It's not divisible by 5, I can tell because it doesn't end in a 0 or 5. And then we back to our repeats. Because top and bottom are positive, I know these are positive, so I'm adding everything. 1 plus 24 is 25, it's too big. 2 and 12 is 14, it's too big. 3 and 8 is 11, that's too big. 4 and 6 works. 4 plus 6 is 10. Next step, we take those numbers and we rewrite our middle term using those two. So 10 becomes 4 and 6. So 3x squared plus 4x plus 6x plus 8. And you'll notice I'm just putting them in the order I put them in my x because order doesn't matter. All right, next step, we're going to factor by grouping. So we need to group first two terms together and the second two terms together. 3 and 4 don't have any common factors, so I'm just dividing that x out. 6 and 8 are both divisible by 2, so I'm going to divide a 2 out of both of those. So for that first grouping, we pull an x out in front, and we're left with 3x plus 4. For the second pair, we pull a 2 out in front, and we're left with 6 divided by 2 is 3, and 8 divided by 2 is 4. And again, we get a check on our work because those two binomials match. 3x plus 4, 3x plus 4. So we're going to factor those out in front. So 3x plus 4, and then we're left with an x plus 2. All right, one more example. I'm hoping the process is starting to feel familiar. You will notice I'm labeling my steps. I would encourage you to do that while you're still learning. Make sure you've got an example next to you while you're working and mirror those steps. We want to keep mirroring them until we don't have to think about the process anymore. Okay, last one. 12x squared minus 10x minus 8. So first step, we look for common factors. All of those numbers are even, so I know that all of those numbers are divisible by 2. So we're going to pull a 2 out in front. And 12 divided by 2 is going to give us 6x squared. 10 divided by 2 is 5. And 8 divided by 2 is 4. So we now have the trinomial 2 times 6x squared minus 5x minus 4. Now we can move on to the second step where we start looking at a, b, and c. So a is 6, b is negative 5, and c is negative 4. So a times c is 6 times negative 5. Whoops, sorry, negative 4. A times c, first and last, which is going to be negative 24. And b is negative 5. So we set up our x, numbers that multiply to negative 24 and add to negative 5. So we know the top number is negative, meaning I know that my two factors have opposite signs. Negative times a positive gives me a negative. Because the bottom is negative, I know that the bigger number, the bigger of those two factors, is the negative guy, so that when I add them, I get a negative answer. When we get to cheat a little bit here, we have a list of factors for 24 because we saw 24 in our last problem. So I am just copying that list from our last problem. 1 and 24, 2 and 12, 3 and 8, 4 and 6. If I do 1 minus 24, I get negative 23, which is 2 negative. 6 minus 12 is negative 10. 3 minus 8 is minus 5. So I know my factors are 3 and 8. I know the bigger number, 8, is going to be negative. So on to step 3, we're going to split up that middle term. So 6x squared minus 8x plus 3x minus 4. And then in step 4, we're going to factor by grouping. So first two terms together, second two terms together, look for what they have in common. The first group has two things. 6 and 8 are divisible by 2. X squared and x are divisible by x. So I'm going to pull out a 2x there. In the second grouping, 3x and 4 have nothing in common. So I'm dividing by 1 because I know everything's divisible by 1. So for my next line, I have 2, and then in parentheses 2x, and then 6 divided by 2 is 3, so 3x minus, and 8 divided by 2 is 4, plus 1, and then 3x minus 4. And again, the check on our work, those binomials should match, and they do. So we can factor out the common binomial. So we get 2 times 3x minus 4 times 2x plus 1. Okay. I'd like you to spend the rest of your class period working on that practice assignment in Google Classroom. It's called, what is it called? It's called Practice Factoring When A is Not 1. And then when I see you on block period, we're going to do a review and more practice together. And then Friday, we're going to tie it all in with our knowledge about intercepts. If you have any questions, feel free to email me. Otherwise, I will see you on our block period.